Okay, we'll begin. I hope there's enough handouts to go around. I've 2 photocopiers broken this morning. I'm trying to get those out. So today we're going to, they're on Blackboard, yeah. So today we're going to look in more detail at consumer choice. So we've introduced the issues looking at individuals rationalise, but as economists, what tools do economics use to model this rational behaviour? How do we model this maximising behaviour? What elements do we use? So when looking at this, we're not necessarily looking at the supply and demand model. In a microeconomics course, you will get to issues in relation to supply and demand. They're at the aggregate sense. Where we're starting off is at the level of the individual. So our assumption is that consumers maximise their utility subject to constraints based on their income and the prices of goods. So the key issue we've looked at thus far have been their preferences, how they maximise their utility, what do they want to do, and now we look at what they can do. How do we incorporate the income that they have, the amount of money and time available, and the prices that exist for different goods and services. So the model of consumer choice is based on the following sort of 3 ideas or 3 concepts. Our first issue is the whole area of preferences. And again, we largely take the preferences as given. That whatever maximises an individual's utility is whatever maximises their utility. They do what they want to do. We don't offer judgment or choose between different sets of preferences. All we're looking for is consistent behaviour. That if a person makes a particular choice, it then feeds through into different choices. Secondly, we assume that individuals face constraints. So economics exists because of scarcity. If we didn't have these choices to make, there wouldn't be the subject of economics. So from the individual perspective, the key constraints, first of all, are the budget, how much money is available, and then secondly, the prices. What quantity of goods and services can be purchased with that budget. So given the individual's preferences, so they are very internal, given the constraints which are largely external, the consumers then maximise their well-being, maximise the utility subject to those particular constraints. So the first issue we look at is what assumptions do we make about consumer preferences? What do we mean when preferences are rational? So if we're looking for consistency, what do we want? That if we're looking for the behaviour to tie into this maximising behaviour. So we make 3 assumptions about the properties of consumer preferences. First of all, we assume completeness. That is, everything can be ranked. So the individual, the consumer, is able to make a choice between everything. Whether his X is preferred to Y, so good X is preferred to good Y, whether his good Y is preferred to good X, or whether the individual is indifferent between them. So X preferred to Y, Y preferred to X are indifferent. That the individual actually can go about making that, that ranking. The second assumption we make is the assumption of transitivity. And this is the key one for consistency. That if X is at least as good as Y, and Y is at least as good as Z, well then transitivity implies that X is at least as good as Z. So if you prefer apples to oranges and prefer oranges to bananas, you should prefer apples to bananas. That there's transitivity, or in some sense consistency, across your preferences. That it's not X is better than Y, Y is better than Z, and then suddenly Z is better than X. That would be intransitive. It would be inconsistent. That if X is better than Y and Y is better than Z, well then X should be better than Z. And the final assumption we make is non-satiation. That simply more is better. That the use and purchase of goods through consumption leads to increases in utility. That more is better than less. So if we take a simple scenario where there's just 2 goods available. So one of the features we do is try to simplify things to make it in a form that sort of is presentable. So you can extend this to a 2, 10, 100, or an n good world where there's as many goods as you wish. But just for sort of simplicity and exposition, we'll start with a 2 good world. So the individual will consume some quantities of pizza and beer, many quantities they wish. So these points here are essentially consumption bundles. So points A to E are consumption bundles. So D represents some amount of beer and some amount of pizza. F represents different quantities. So you can see moving towards the top right hand corner is increasing quantities. So both start at 0. Up along the vertical axis, greater quantities of beer. Out along the horizontal axis, greater quantities of pizza. So each of these is just a consumption bundle. So the individual consumes different quantities of each. So at point E, it's a certain quantity of beer and a certain quantity of pizza. So you can then make judgments. But what are the consumer's preferences? Well, if you look at any consumption bundle in area A, so the one we have is consumption bundle D, it has a lower amount of pizza and a lower amount of beer. Bundle D has lower amounts of both. So we can clearly see that any individual would prefer E to D. It has less of both goods. Whereas if we go in the opposite direction and move out to the right and look at bundle F, you can see that it has more than bundle E. So while D is less preferred, F would be more preferred. So making judgments in areas A and B is fairly straightforward because of our assumption that more is better. Anything down here has less of everything. Anything up here has more of everything. It's a bit different then when you look across the diagonal. If you look at bundle C, bundle A, bundle B, these have more of one good and less of another. So this isn't as straightforward. It's not simply a case of having more of both. Once you go into this diagonal here, so point C has more beer for the individual but less pizza. Point B has more pizza and less beer. So you're playing one off the other. Is the extra utility from having the additional beer, is that sufficient to offset the loss of utility by having the lower amount of pizza? So we can see that for some of them, the judgment is fairly straightforward. But for others, it's not as straightforward. So the preference direction is up and to the right. Anything up and to the right is better. Moving in this direction here, that gives us more of both goods. But if we're going in this direction, or going in this direction, it's less straightforward. So we can make what are called indifference curves. Bundles of goods that offer the same level of utility. But the fact that a consumer has lost some of one good and gained some of another. That along the indifference curve, utility is exactly the same. So C, E, and B all have the same level of utility. They're all different combinations of the two goods. Certain combinations have more of one good and less on the other. But as a consumption bundle, they offer the same level of utility. So anywhere along that line, any bundle of goods along that line, the individual is indifferent between them. And that's where the name indifference curves comes from. That if you offer the individual any bundle of goods along the line, they're equally likely to accept it because they get the same level of utility. The issue arises then when you move off it. So the objective for the individual is to get on the highest possible indifference curve. The indifference curves cross through every good. So now for the individual we can see that E, C and B are all the same because they're all on the same indifference curve. And now we can also make comparisons between different goods in the quadrants down here. So we can see good A. How can we make a comparison between A and E? Well, we know that A is better than B by our more is better principle. A has more of both goods than B. It's further up to the right. We know that B is equal to E. So then if we're going to compare A to E, A is better. Simply by using the transitivity assumption. So we have A is better than B. It has more of both goods. We know that B is the same as E. So therefore A is better than E. So we can make comparisons across all bundles of goods using these indifference curves. So give the consumer a particular bundle of goods. And if we can, in a sense, rank or align bundles of goods that are the same, we get an indifference curve. So it's through the space of pizza and beer, but all bundles of goods along it are equally desirable. And then we can draw different indifference curves. We know that D is worse. So clearly down here, the person has less utility. They have less of both goods. Their consumption is less. So because of that then, the goods along this indifference curve here have a lower level of utility. They all have the same level of utility, but because D is lower than E, and we know it by the quantities, indifference curve I0 is a lower level of utility. So the objective of the individual, the preferences of the individual, are to move as far out in the top right direction as possible, to consume as much as possible. If there was no constraints, they consume as much as they wanted. So we have different indifference curves to all different points. And the assumption of completeness means that the indifference curves are what are called everywhere dense. There's an indifference curve to every single point, because we assume the consumer can rank each and every different bundle of goods. So we get what's called an indifference map, a whole set showing the individual's preferences, that along an indifference curve, the level of utility is the same, and that as we move out to the right, the level of utility increases. So we have an indifference map. So it's a complete set of indifference curves that summarize a consumer's tastes. How do they choose between the different goods? So in this instance, we're just using two goods. Well, that's really all you can use in a graph. But if you were to extend it and look at it sort of in a mathematical sense, you can have any number of goods you want. 2, 10, 100, 1,000. So just for simplicity, we use two goods. But the analysis isn't limited to two goods. So indifferent maps have four important properties. First up, indifference curves further from the origin are preferred more. Indifference curves further from the origin have a higher level of utility. There's more of both goods. Secondly, there's an indifference curve through every possible bundle. That's because of the assumption of completeness. The third property is indifference curves cannot cross. That's because of the assumption of transitivity. And fourthly, indifference curves slope down. And they do for economic goods. If we're not looking at economic goods, they don't necessarily slope down. So what does the indifference curve tell us? How can we, in a sense, get an indication of the individual's preferences from the indifference curve? Or how can different preferences feed into different indifference maps? Is it just a case that this is the only set of indifference curves we can draw, and we sort of have to impose this on everybody? That these are your preferences. There are certain bundles of goods you rank the same, and there are certain bundles of goods that have lower and higher levels of utility. Does it actually apply to everybody, or is it just sort of an abstraction that looks like a useful graph in theory, but has little use in practice? But as we can see, the indifference curves actually can fit in around all sets of preferences. That once you look at the choices people make, you can incorporate any set of preferences into indifference curves. So a very important feature of indifference curves is the marginal rate of substitution. So with the two goods, how willing is the person to swap from one good to the other? So along the indifference curve, we say that the utility is the same. But if we give the person more beer and we take pizza off them, what is the utility implication of that? How much more beer must the person get so that the utility stays the same? So what we've look at is the slope. So a consumer's willingness to trade, so the willingness to swap one good for another. How much of one good must they gain to offset the loss of losing one of the other ones? And this is measured by what's called the marginal rate of substitution. So again, decisions are made at the margin. So it's not a case of the total amount of pizza and beer they have. It's the change. If they lose a certain amount and gain a certain amount, what impact do those changes have? So the margin is the extra. The margin is the change. So we're looking at the marginal rate of substitution. So this is the maximum amount of one good a consumer will sacrifice to obtain one more unit of another good. So say the other good was something the person didn't want at all, wasn't going to add or increase their utility. How willing would they be to swap in this instance? So the marginal rate of substitution is just based on changes. So D here, or delta, the Greek delta, just reflects change. How much of one good are you willing to give up for the other good? So dy dx, or delta y delta x. How much must the change in each good be? So the marginal rate of substitution is measured by the slope of the indifference curve. So how quickly must one good rise or fall to keep your utility constant? If you're not willing to accept that your utility mightn't change very much at all. So the slope of the indifference curve reflects the consumer's willingness to change, to go from E to C. How much of beer must they get extra, and how much pizza must they lose, so the utility holds constant. So indifference curves slope downward from left to right. So the implication is a consumer is willing to give up some of one good, so that's a drop, for more of another good, again. So the consumer will swap one good for the other, and that will keep the utility constant. So what does the curvature mean? Can we actually fit different preferences into it? So most indifference curves are what's called convex to the origin. That just simply means they're bowed to the origin. So the slope means that they bow into the origin being the point 0, 0, the start of the graph. So when people have a lot of one good, they're willing to give up a relatively large amount of it to get a good which they have relatively little. So if you take an individual where there's a very large amount of one good, so take point D here. So at point D, the person has 6 units of pizza and 2 units of beer. So their consumption bundle isn't very balanced. It's heavily weighted towards one or the other. So at point D, if they were to give up 1 unit of pizza, they'd be happy enough to accept 1 unit of beer and have the same level of utility. So D and C are the same. So when they have 6 units of pizza, they say, look, I've plenty of that. To get up to 3 units of beer, I'm willing to do a 1-for-1 swap. So the marginal rate of substitution will actually be a 1-for-1 swap. The slope would be 1. Whereas if you take point B, and say the individual at point B has 4 units of pizza, now their quantity of pizza has dropped. If you're going to drop the quantity of pizza by 1 unit again, so again the change is 1. So from D to C, they drop 1 unit of pizza, and from B to A, they drop 1 unit of pizza. But there's a big difference between dropping from 6 to 5 and then from 4 to 3. Going from 4 to 3, the quantity of pizza is getting relatively small. Now their consumption bundle is no longer balanced. And in fact, to give up from 4 to 3, they'd need to be compensated by much more of the other good. So in fact, in this instance, there'd need to be a rise of 3 to keep the utility the same when going from B to A. So they've got to the stage where the quantity of one good is getting sufficiently small that they need to be compensated by a greater amount. So the marginal rate of substitution is measured by the slope, and the slope changes. So up here it's quite steep. The marginal rate of substitution is quite high. It's a 3-to-1 ratio. As you move down along the the indifference curve, the slope gets flatter and flatter. And by the time you're moving between C and D, the slope is 1. So indifference curves become flatter as you move down to the right, simply reflecting the fact that if you give a person more and more of one good, they're actually willing to give up that good and get some of the other good to balance out their consumption. So the willingness to trade fewer beers for more pizza, or the willingness to trade, in a sense, the other direction, as we move down along the indifference curve, reflects a diminishing marginal rate of substitution. If you give somebody more and more of the good, it's actually worth an amount less to them. If they have 6 units of pizza, where is the gain in going out to 7? Their consumption of that product is already at a high level. The extra utility is likely to be quite low. Whereas if they're only at 2 units of beer, well, giving them the third is likely to have a bigger impact on their utility. So the rate of change, the rate of substitution differs. It's not constant. It's not like that 1 unit of beer is equal to 1 unit of pizza and that stays the same. It actually depends on the consumption bundle, how much of each good they have. So again, up here, after 8 beers, they're willing to give up 3 to get an extra unit of pizza. Whereas down here, if they have only had 3 beers, they're only willing to give up 1 to get an extra unit of pizza. So the rate of substitution changes or differs. So a diminishing marginal rate of substitution is based on the fact that people prefer balanced consumption bundles. If you look at the goods we purchase, we don't tend to spend all of our money on 1 or a few goods. Our consumption is spread or distributed across 10, 100, hundreds of goods. So our consumption tends to be quite balanced. So if you look at an individual's consumption bundle, so here is an indifference curve A, B, C, D. These all offer the same level of utility. So A, B, C, and D are all on the same indifference curve. But if you took the average of A and D, which are at the extremes, so the midpoint between A and D is this point G, you can see that G would be on a higher indifference curve. G would actually be preferred to both B and C if you give them the average of A and D. So the person would prefer a balanced consumption bundle. So if you offered somebody A, G, and D, which all are just variations of each other, they are all on a straight line. So if we look at just units, this could be 8 and 2. This could be 2 and 8 down here. And this would be 5 and 5. They'd all have the same number of units. All would be combinations of each other. But because G is more balanced, it has an even amount of both goods, G would be preferred. When moving out to D, when getting this huge quantity of pizza, there isn't really a huge utility gain. The person has enough of it already. Moving out and getting even more of it isn't going to offer a huge increase in utility. And the same in moving from B to A. They have a quantity of beer at present, and getting even more isn't going to offer a huge quantity. So an average consumption bundle is preferred to an extreme. So G is preferred to either A or D. So how do we incorporate different sets of preferences? Well, in some instances, the person is completely indifferent between the goods. The goods are perfect substitutes. So it's not simply a choice between something like pizza and beer. In many instances, goods could be identical. Different brands, different types, are goods that serve the exact same purpose. So whether you give the individual one or the other wouldn't make a difference. So in this instance, a diminishing marginal rate of substitution would make no sense because the goods are identical. The person is equally willing to swap one for the other. So there are perfect substitutes. So a contrived example could be somebody who views Coke and Pepsi as being perfect substitutes. And clearly there are many people who wouldn't, but there would be some who would view them as being interchangeable. That 1 unit of one is exactly the same as a unit of the other. So the indifference curves for perfect substitutes are straight parallel lines with a constant slope. And the reason the slope is constant is the person is equally willing at all times to swap one for the other. That 4 units of Coke offers the exact same utility as 4 units of Pepsi. And whether it's 1 and 3, 2 and 2, 1 and 3, or 4 and 0, the utility is exactly the same. So the goods are perfect substitutes. So the slope of the indifference curves here is -1 at all times. The person will swap them on a one-for-one basis, regardless of where they are in the indifference map. So parallel straight lines. Of course, the marginal rate of substitution for perfect substitutes doesn't have to be -1. Okay, in this instance, it's a one-for-one swap. A 330 ml can of Coke versus a 330 ml can of Pepsi. But maybe €1 coins and €5 notes will be perfect substitutes. You offer or owe somebody a fiver, they'll be largely indifferent between whether they get 5 €1 coins or 1 €5 note. So in this instance, the marginal rate of substitution will be -5. They'll be willing to get 1 €5 note for 5 €1 coins. So it doesn't necessarily have to be a one-for-one swap. So the marginal rate of substitution between the coins and the notes would again be constant. But the slope in this instance would be -5 rather than -1. A second type of good are perfect complements, where actually you need both goods in order to get satisfaction utility from them. So again, there's fixed numbers. And in fact, if you have more of one good, there's nothing really you can do with it. So a contrived example, or a simple example again, would be cars and tyres. So for every one car you have, you need 4 tyres. If you have 2 cars, you need 8 tyres. If you have 3 cars, you need 12. There is fixed ratios in which the goods must be consumed. And if you get extra of one good and not the other, well, it doesn't really add to your consumption. So if you have 1 car and 8 tyres, there's no utility increase. All you need is 4. If you have 8 tyres, you just have 4 sitting on the ground somewhere. They're of no use when it comes to consumption. So whether you have 4 tyres and 1 car, or 8 tyres and 1 car, the utility is the same. So the utility is horizontal, away from the fixed ratio. So more and more tyres doesn't add anything. And if you have only 4 tyres, what's the point in having 2, 3 or 4 cars? You've only got 1 set of tyres you can use. So having the additional cars is of no use. You can't use the extra goods. You actually need more of both goods. They must be consumed in fixed quantities. So for perfect complements, the indifference curves are right angles. That you need to be sort of along this radius here, where you're consuming the goods in a certain proportion. So for cars and tyres, it's 4:1. So the right angles run away from the origin, whose slope is the ratio in which the goods are consumed, 4:1. So they're sort of the extremes. What about where people just have preferences? Prefer one good more than another? Isn't so much a case of consuming them in fixed quantities, like perfect complements, or completely indifferent between them, like perfect substitutes. What if a person has a strong preference for one good over another? Well, these can be picked up with the slope or shape of the indifference curve. So in some instances, the slope can be relatively flat. In other instances, the slope can be relatively steep. So these reflect the goods the person wants. How much of one good are they willing to give up to get the other good? So if you look at the indifference curves that are flat, this person here has a strong preference for beer. If you take a point low down in the indifference curve here, they're willing to give up a huge quantity of pizza, go from here to here, for a small gain in beer. So a very strong preference for beer shown by person 1, willing to give up large amounts of the good on the horizontal axis for a small gain in the good on the vertical axis. So again, the strength of preferences can be picked up. And if you look at person 2, they have a strong preference for beer. They have a strong, or sorry, for pizza, a strong preference for the good on the horizontal axis. Again, if you look at indifference curve I1, they have a lot of beer. In fact, they're willing to go right down to the bottom and get only a small increase in pizza and still say they have the same level of utility. So indifference curves can reflect relative desirability. How much do I rank or rate one good over another? So it's not just a fixed shape that we impose preferences on, that you can actually have different sets of preferences incorporated in an indifference map. So person 1 prefers beer to pizza, is willing to give up large amounts of pizza for a small gain in beer, and person 2 is the opposite. They're willing to give up large amounts of beer for small amounts of pizza. So again, you can pick up different preferences. So again, we don't make any judgments about these two individuals. We're not saying one set of preferences is better than the other. We're not saying that one person gets more utility than the other. These interpersonal comparisons are largely meaningless because we can't judge across people. Utility doesn't cross across individuals. So it's not the case of saying that this indifference curve here has the same level of utility as this indifference curve over here. We cannot make that judgment. These are different people. They have different preferences. All we're saying is that for this person, they prefer beer to pizza, and we're saying for this person, they prefer pizza to beer. And we can then look at the choices they make. What combination of both goods do they want? So again, they want to be on the highest possible indifference curve. So for person 1, they'd prefer to be on I1. And for person 2, they prefer to be on I3. The issue is, how does that type in with their preferences? So you can see the rates of substitution differ substantially. So for person 1, only willing to give up a small amount of beer for an extra pizza. For person 2, a dislike for it, willing to give up a much greater amount for an extra unit of pizza. So you can incorporate different preferences. So for person 1, the marginal rate of substitution is a half. Only willing to give up half a beer for one extra unit of pizza. For person 2, it's 2.5. Willing to give up 2.5 units of beer for an extra pizza. So their relative ranking of the goods are different. They prefer one good to the other. So the shape or slope of the indifference curve incorporates the preferences, whether it is sort of the unique preferences that are substitutes and complements, or the choices people make. Again, just like a couple of lectures ago when we said people can be selfish or selfless. Like, you can incorporate those into indifference curves. Wanting to help others, wanting to help yourself. Gordon Gekko, Mother Teresa. All types of preferences can be fitted in to the indifference map. In general, we consider economic goods. So these are goods that offer utility when consumed. There are useless goods, ashtrays and motorbikes, which offer no utility. So getting more of them means absolutely nothing. So with a useless good, whatever it might be, something that offers zero utility, having more of it means absolutely nothing. I'm sure we can all think of things that are absolutely useless. Whereas with the economic good, so we'll take the one that's on the horizontal axis, pizza, having more of it means we move to a higher indifference curve. So I2 is a lower level of utility than I1 is a lower level of utility than I2, which is a lower level of utility than I3. And then there are economic bads, goods which offer disutility, which we'd like to have less of. So it could be something like pollution, etc. So goods which actually, if there's more of them, they decrease utility. So with the economic bad, we want to get as far away as that as possible. So the preference direction is away from the economic bad, a reduction in that quantity, but it's still an increase in the quantity of the economic good. So the preference direction is down and to the right. But in general, we consider choices between two economic goods, two goods that offer positive levels of utility. Useless goods are at 0. There's no point in having them. Economic bads are negative. More of them leads to a reduction. So we can use or in difference curves to kind of track, map, or plan out any set of preferences. So they're not tied to one set of preferences. We can also do it with numerical values. So when firms maximize profit, the euro value of the profit is easy to measure. We can do something similar with utility and say, can we work out some utility number? Again, it doesn't have interpersonal comparison. But again, a utility level of one number that's higher is better than one of a lower number. So you could multiply two goods together and get the square root of it. So look at the quantities. How many units of each good did the person get? And just get the square root. So this is what's called a utility function. And this contains the exact same information as an indifference curve, just in a different manner. We gauge indifference curves by those that are further from the origin, have a higher level of utility. We don't need to know the number. We just simply need to know that indifference curves that are further from the origin are at a higher level of utility. We could actually put numbers on them. So we could say that for person 1 here, this is 15 units of utility, this is 10 units of utility, and this is 5 units of utility. The numbers don't really mean a whole pile. It's the ordinal ranking that matters, the order, that 15 is greater than 10 is greater than 5. So as long as we have something that gives us the order, it serves our purpose. So it could be a utility function like that. Multiply the units of both goods. So beer is the units of beer, pizza is the units of pizza. Multiply them together and get the square root. So utility functions do not exist in a fundamental sense. We don't have this concept out there where we can measure utility. There isn't a utility thermometer that says you got 10 units of utility from that good. So we may know a consumer's relative rankings of bundles, but are unlikely to know by how much. But by how much doesn't really matter. What we need is the order. So right at the very start, we said that individuals can rank them by order. And that's all we really need to know. And then as long as our utility function gives us the same ordering, it's useful. So as long as those bundles that are preferred more have a higher utility number than those bundles that are preferred less, that's all we need. So we should not put much weight on the absolute difference. So if one utility bundle has 10 and the other has 5, you can't say that one is twice as good as the other. The actual gap between them doesn't really matter. All that matters is the relative ranking. 10 is bigger than 5. So you could put numbers on these here. 15, 10, and 5. So on Wednesday we'll see how utility functions work. And then we can map those into individual preferences. So we'll leave it at that for today.